Welcome back to Swayam MOOC on Biostatistics and Mathematical Biology. So let us continue our first module, which is Introduction to Biostatistics and Mathematical Biology. This is our third and final section of that particular module, the first module, and this section is entitled Scientific Methodology. So scientific methodology is developed in British philosopher Sir Francis Bacon's seminal publication Novum Organum, published in 1620. So earlier than this reasoning, the logical reasoning is believed to have started with ancient Indian systematic thinkers. For example, Panini's Sanskrit grammar, that was a systematic inquiry, and it's absolutely scientific in a way. And so as the Greek, the Aristotelian logic, or Plato in logic, or all those Socrates, for example, all those actually those were systematic inquiries. So all those are kind of science, but formal scientific methodology have been started with Sir Francis Bacon's Novum Organum. So it's very important book. So it was published in 1620. So this particular work involves inductive reasoning from observations and experiments. So it's basically about inductive reasoning. So induction, as I explained to you, it is bottom-up logic or a posteriori reasoning, right? Inductive reasoning. So Baconian method, because it's by the Francis Bacon, that is why it's called Baconian method, that frames what it construes as a scientific methodology. The formal scientific methodology is started from the Baconian methods, right? It's logical, rational, systematic, reproducible, empirical, evidence-based methodology to test a hypothesis in question. So you have a hypothesis, so you actually test that hypothesis with that particular logic, right? So that is actually in a way statistical hypothesis testing is, it's not a inductive, but it's a deductive. It's actually testing a prior hypothesis, right? It's a priori, right? So observe without preconceived notion. That is the hallmark of scientific methodology. You observe the things as it is without any preconceived notions, without any confirmation bias or any of these cognitive biases, as we explained that in our last module. There is a famous conundrum. That is something called Russell's Teapot by that of course by the Russell, the famous British philosopher. So a usual tactic for the pseudoscience proponent had always been philosophical burden of proof exploits. So what is this exploit? Burden of proof. So it's up to you to prove it otherwise, right? If I make some claim, prove it otherwise. That is called the burden of proof. The proof is not with the proponent but the opponents, right? You're actually asking the opponent to prove that it doesn't work. For example, panacea, that is cure for all remedies. These kind of formulations usually claim to have a mystic or ethereal essence, induced by indecipherable chants and bizarre rituals, right? So that is why it is very highly unlikely to prove otherwise wrong. So there is nothing to prove. So there is no actually possibility for proving it as wrong. So it is actually an exploit for burden of proof. So it is ever possible to disprove the efficacy of mysticism? Is it ever be possible to prove that, disprove that efficacy? So it is nothing, it's almost impossible to disprove any kind of argument. So that is why the British philosopher Bertrand Russell, he made a satirical claim that there exists a teapot, a small teapot, that is something called Russell's teapot, that is actually revolving around the sun in between Mars and Earth, the Kuiper belt. So it is actually revolving around the sun. So how do you prove it that it is doesn't exist there? So if you do not believe in the teapot, go and disprove it. So it is almost impossible to disprove that kind of claim. Why? Because even with the super telescopes of today, it's not possible with that kind of fine resolution to diverge a teapot in that particular vast expanses of space, right? So those who do not believe in its existence should prove it doesn't exist. So of course it is impossible to prove it otherwise wrong. So proof by negation and contradiction is a standard in scientific experimentation. Because of the issue with philosophical burden of proof, it was Ronald Fisher, as I told you in the first session, the father of statistics is Ronald Emil Fisher, right? So that particular scientist, the statistician, he based his statistical significance testing with initial assumption of negativity. It's not about positivity. Initial assumption is negativity, which is like null hypothesis, right? So in the statistical hypothesis testing, a null hypothesis of no effect is assumed to be true initially. So initial assumption is that null hypothesis is valid. So validity of this assumption is then tested with data from alternative hypothesis. So alternative hypothesis that, you know, it is actually effective, the drug is effective, for example, while null hypothesis that drug does not cause any effect, right? So that kind of thing. So these are something called proof by negation and contradiction, the approach of philosophy and logic. You know, it is in law also, in the jurisdiction, these kind of things happen, but in everyday life it is quite hard to resort to this kind of philosophical method of contradiction, right? Negation, right? So that is one reason that the significance testing as well as p-values are so confusing to the layman, and also those who have never taken a course on formal logic or philosophy or even law. It is you know, seemingly quite difficult to understand how the p-values work, because it works by, you know, contradiction and negation. So scientific methodology involves observations, experiments, and statistical hypothesis testing. So these are the hallmarks of the scientific methodology that is actually developed by Carl Pearson, Ronald Fisher, you know, Jerzy Neyman, and Egon Pearson. So the son of the Carl Pearson, Egon Pearson. So these are the scientists and biostatisticians who are behind scientific methodology of statistical hypothesis testing. So it is, you know, it is based upon proving or disproving. You know, it's an important hallmark of the scientific methodology, to prove or to disprove. So a principle called falsifiability, to falsify or, you know, to disprove it, that is called the falsifiability of a famous British philosopher of science Karl Popper. You know, that is the principle is called falsifiability. That is extremely important hallmark of modern scientific methodology, right? And falsifiability is a kind of a deductive reasoning, because it's deduced from general to specific, deductive reasoning, right? Or a priori reasoning. Falsifiability. So scientific claims have to be falsifiable. It's a possibility exists to show it to be false. So there should be a possibility that exists to show that it doesn't work, you know, to nullify the claim. So there should be a possibility. If you are making some claim, has, you know, bizarre claim that cannot be invalidated, then those claims are not part of the science. So that is actually very simple. So science is open to the criticisms and to refine and to improve. This is the hallmark of the scientific methodology. So there is always you know, an option to improve it. You know, there is something called feedback loops of improvement. That is a hallmark of the science, while pseudoscience do not have that kind of hallmark of feedback loop based further improvement, right? So declaring unfalsified claims as scientific is what you call pseudoscience. So pseudoscience is declaring something as scientific without any evidence. So that is called pseudoscience. So according to Popper, the Karl Popper, science progresses by sequential falsification of older hypotheses. Eternal cycles of conjectures, refutations, conjectures, refutations. So if I make a theory, my subsequent generations will refute it, and he or she will put up another conjecture, and then refutation, conjecture, refutation. So the cycles of falsification moves the science forward as per the Karl Popper's falsifiability. So gradual progress through methodical, systematic research aided by the statistical hypothesis testing is the hallmark of the Karl Popper's falsifiability. Now if you look at most of the tangible products of today's world, for example, the mobile phone, computer, internet, electricity, GPS, radar, radio, television, air conditioner, x-rays, aircraft, laser, electric engines, even you know, the antibiotics, vaccines, advanced genome editing tool, CRISPR-Cas9, Velcro, so many tangible goods, right? But now the hallmark is that none of these products were developed through the systematic statistical hypothesis testing based science. So how does the science breakthrough happens? There is a famous theory or conundrum by the American philosopher called Thomas Kuhn, and that is called the paradigm shift. According to paradigm shift, science progresses through unconventional revolution of the ideas. That is called the paradigm shift of the Thomas Kuhn. So the revolution of the idea, that is how the science progresses, right? Most of the key innovations in science, happens through the lucky finds. These are through the sheer chance, right? And trial and error strategy is responsible for the vast majority of the scientific principles and products, rather than discoveries through systematic research. It's a serendipity is a norm of science. So the chance discovery is how most of the science progresses. So if you look at the curiosity driven science and utility driven science, so many of the scientific fields are curiosity driven, while applied, the basic ones are curiosity driven, while applied sciences are utility driven, where the statistical hypothesis testing is a norm, while the curiosity driven, it is basically out of curiosity, out of observation, while in the case of utility, it is mostly by the experimentation, carefully planned systematic explorations, experiments. It is actually curiosity driven science is in response to an innovative idea or observation or an exploration, right? So there is no prior hypothesis in the case of curiosity driven, but utility driven there is actually a hypothesis, right? And of course some examples of the curiosity driven fields are evolutionary biology, taxonomy, ecology, exobiology, astronomy, quantum physics, mathematics, logics, geology, paleontology, biogeography, animal behavior, ornithology, theoretical chemistry, theoretical physics, ecology, and so on. In the case of utility driven fields, which is actually experimental, and statistical hypothesis testing is actually a norm in this case of the utility driven. Examples are agriculture, medicine, pharmacy, food technology, engineering, biotechnology, nanotechnology, and all applied sciences. So those are utility driven. So that is actually Popper's falsifiability is probably applicable for the utility driven, while in the case of curiosity driven, it is basically by Kuhn, Thomas Kuhn's paradigm shift, right? So that is what is actually applicable. If you would like to know more about the falsifiability of Karl Popper, I strongly suggest you to read this particular book. This is called The Logic of Scientific Discovery by Karl Popper. So this is one of the famous book, and we will be covering some of the fundamentals of this book as part of this course. So this is a fantastic book. I suggest you all to go through it, this particular book. Probably you will get this book in your local library. And another book is called The Structure of Scientific Revolution by Thomas Kuhn. So this is yet another book. This is actually the book that explains the paradigm shift. Both are classics, so most probably you will be getting this particular book also from your local library. Now coming to pseudoscience, so claiming something to be scientific and factual in the absence of evidence is what you call the pseudoscience. So the pseudoscience is actually not really science, right? It can be contrasted from non-science. For example, fields such as language, arts, humanities, and so on. These are all non-science, yet these disciplines follow systematic research methodology, and therefore these fields are highly reputed, right? It's not like pseudoscience. Pseudoscience is something different, right? And it's also different from erroneous science, either deliberate or through the scientific misconduct. For example, the cherry picking, which we explained in one of our earlier sections, or undeliberate through the bad science. If you don't know how to actually interpret the data, or if you don't know how to do that experiment correctly, those are called bad science. So sometimes you want to actually deliberately want to do certain misconduct, right? That is scientific misconduct. So those are called erroneous science, and that is different. Non-science is different, while pseudoscience is something called that you are claiming something to be scientific without any scientific evidence. So that is called the pseudoscience. So pseudoscience has none of the elements of scholarly scientific methodology. Instead of logic and reason, It tries to appeal through emotions such as mysteries and miracles and irrational anecdotal records. So that is the hallmarks of the pseudoscience, right? Instead of logic and reason, it is mostly by the emotions and anecdotes, right, and mysteries. While pseudoscience tries to confirm its theories, science tries to disconfirm on hypothesis. So if I make a hypothesis, probably later I or my peers or my next generation would try to disconfirm my theory. That is how the science progresses, right? Through falsification of the Karl Popper, right? But in the case of pseudoscience, it wants to confirm that old hypothesis, right? Again and again they want to confirm, and the dissension is not welcome in the case of pseudoscience. So in summary, scientific methodology was developed by Francis Bacon's 1620 classic Novum Organum. Ronald Fisher and others introduced statistical hypothesis testing. They formalized statistical hypothesis testing. So statistical hypothesis testing involves initial assumption of negativity, an assumption that the null hypothesis to be true, as an answer to the philosophical burden of proof exploits. The proof by negation and contradiction is only sparingly adopted outside sciences and logic and law, right? And that is the reason that it is being misunderstood by most of the laymen and those non-specialists of the scientific field. So in contrast to the science, pseudoscience appeals through emotion, anecdotes and mysteries. It masquerades the public as the ambassadors of the real science while evading Popper's falsifiability with unverified claims. I hope you had a nice time watching this particular session, and I wish you the very best to continue this particular course. And this is the end of the module number 1, and now we will actually move on to our second module. Thank you.